So in this class, we'll cover the theory about exceptions. So what are exceptions? Exceptions are basically some events that disrupt the normal flow of the program. So your program is running in a happy path scenario where everything is working as expected, but if something that you don't expect happens, then it generates an exception. An exception in Java is a class. And there are different kinds of exceptions, and there is a exception hierarchy provided by the JDK API as well. So an exception object, it basically contains a cause on why that exception happened, and the cause can be another exception also. So an exception can contain another exception which can contain another exception. Okay, and it will have a detailed message on why the exception happened. And the exception can be thrown programmatically by using the throw keyword. And it can be caught programmatically by using the catch keyword. So there are two important keywords when it comes to exception: throw and catch. So what are the benefits of exception handling? So instead of writing your exception handling code, the same block of code, you separate your normal execution of code and the exception handling code. So the code is not cluttered with exception handling code within the normal processing of within the normal execution of the program. So you get cleaner code by separating in the error handling code from the normal or happy path code. And then if you cannot handle an exception at the point where it occurs, you can propagate it up the call stack. So you propagate it to the caller of your method, and if you cannot handle it there, it can get propagated even way up. So you can propagate the errors up the call stack, and you handle it at a point where you can do something meaningful with the exception. And you can also categorize exceptions using the exception hierarchy. So there are different kinds of errors in Java. One, we have the JVM errors. So this includes errors like out of memory error, where your program runs out of heap memory, or there is a stack overflow error. That happens when you have a recursive program which never ends. So there is a stack overflow. And then there is a linkage error when a class cannot be found. So these are all errors coming from the Java virtual machine. Then you also have system errors where you're trying to open a file and the file cannot be found, so it will throw a file not exception. Or you're trying to write to a file to which you don't have permissions and it will throw an IO exception. Or you make a programmer mistake and it throws a null pointer exception. A programmer mistake can also result in an array index out of bound exception when you're accessing an array element beyond the length of the array. Then you also have another kind of exceptions called application errors, which are more user defined exceptions. And these happen because of some kind of a business logic is not being satisfied. Let's say, for example, you're transferring funds from one account to another account, and the amount of funds is more than the balance amount of funds that you're transferring is more than the balance on the account. Then in your code you can throw like a user defined exception like called insufficient funds exception. Okay, so the JVM and system errors are all built-in exceptions, whereas application errors are user defined exceptions. So this is the application hierarchy. So the root of all exceptions in Java is throwable. From there you inherit the error and the exception, and from the exception you inherit all these different kinds of exceptions like IO exception, runtime exception, interrupted exception, and then runtime exception has arithmetic exception, index out of bound exception. So these are all the exceptions that are provided by Java for you. Similarly to the you can create the user defined exceptions can also have their own hierarchy. So within your own application, the user defined exceptions that you create, they may also have some inheritance structure. In exception handling, there are three important keywords: the try, the catch, and the finally. So there are different blocks. You all know what a block of code is, right? A block of code is something which is between the opening brace and closing brace. So it is a group of statements which all execute within the block, within that block. So the try block is the block of code which executes in the happy path scenario. That is the normal flow of execution of the code. If something bad happens during the normal flow of execution, then you have what are called as catch blocks, where you handle the exceptions generated in the try block. So in the catch block, you can have one or more of those, and this is where you have the exception handling code. And these catch blocks are like if-else-if statements. So only one of them can potentially get executed. Like in if-else-if statements, only one can execute, right? Similarly, in catch blocks, only one can execute. Once it catches an exception, it will not go to the other catch blocks. Then you have, and then one important thing to remember is when you are catching a set of exceptions in your catch blocks. Let's say you are catching a specific exception and a generic exception. You should always catch the specific exception first and then catch the generic exception, because even among exception objects which have an inheritance relationship, there is an easy relationship. So if you try to catch the generic exception first, even the specific exceptions will go into that particular catch block. So I have covered this in some of the demo programs. So always catch the derived class exceptions first before you catch the base class exceptions. So that's an important point to remember. And if an exception is thrown that is not handled, it will be propagated up the call stack. And then finally block is where you write some cleanup code. Let's say you have opened some file. You want to close the file before you exit out of the method. Let's say we have opened a database connection. You want to close the database connection before you close it. Let's say you have opened a socket to write something to that socket. You want to close the socket before you get out of the method. So that's where you do all the cleanup code. So the finally block will always get executed, even when you have a return statement in your try catch block, or even if an exception is rethrown from the try catch block. So the finally block will always get executed. The only time the finally block will not get executed is if the JVM crashes or if the currently executing thread is abnormally terminated or the system runs out of memory. Okay. There are two types of exceptions in Java. These are called as checked exceptions and unchecked exceptions. Checked exceptions are the compiler will force you. So if a method throws a checked exception, it has to declare it in its method signature. When you declare the method, you have to say it throws this exception. It appears after the parameters are declared. The compiler will force, and if some caller invokes that method, the compiler forces the caller to either catch the exception, or if you cannot catch the exception and do something meaningful with it, you rethrow that exception, or you declare it in the throws clause of the caller as well. And this goes on all the way up to the point where somebody can handle it or you catch the exception. And there are unchecked exceptions, and these are the errors in the runtime exception, and the compiler does not force you to catch them. Like programmatic errors like null pointer exception or arithmetic array index out of bound exceptions, these are all runtime exceptions. Or like the out of memory error, these are unchecked exceptions and you are not expected to catch them, and the compiler does not expect you to catch them. So the application cannot recover from these errors, then you use unchecked exceptions, and you use checked exceptions where the application can recover from those errors. And then you have the concept of user-defined exceptions, which are the business or the application exceptions. And all these exceptions, generally the convention is to end the class name with the string exception. Like for example, insufficient funds exception or account closed exception. Like for example, you can throw an account closed exception when somebody is trying to withdraw from an account which has already been closed. Then you throw an account close exception. And if the user defined exception is a checked exception, then it should extend the exception class. If it is an unchecked exception, then it should extend the runtime exception. So if you go back, if you see from the throwable, you have the exception and the runtime exception. So if you are creating a business or application exception which is a checked exception, then it should extend the exception class. And if you are creating an unchecked exception, then it should extend the runtime exception class. And then in your user defined exceptions, you can add some custom fields or getter and setter methods to capture more information that information related to that exception surrounding the if there is some certain context information in which that exception happened, then you can add that as fields of your exception and capture it, and later on you can display when you actually do something meaningful with that exception. And exceptions, like I said, they can also contain other exceptions. Like in the very first slide I said, an exception can have a cause. The cause can be another exception. Okay, so many APIs, they throw a generic exception which contain an implementation exception. For example, when you come to the Spring framework, you will see that there is an exception called as a data access exception. So whenever you do anything with a database, any method calls, Spring always throws a very generic exception called data access exception, and that internally contains another nested exception, which is the SQL exception which happened when you are trying to do something with the database. So these are called as nested exceptions. And if you want to get the actual cause, then you invoke the getCause method of that exception. So let's say if I want to find the actual SQL exception that happened, I invoke the getCause method on the data access exception, which is the API exception. So some of the recommendations when it comes to exceptions are, you should always use exceptions for exceptional conditions. Don't try to use exceptions for within the normal flow of execution. And then you use checked exceptions for recoverable errors and runtime exceptions for unrecoverable or programming errors. And catch exceptions only when you can handle them meaningfully. If you cannot do anything meaningful with it, rethrow it and propagate it up the call stack and handle it at a point where you can meaningfully address it. And as far as possible, try to use the standard exceptions provided by Java. Only when you have a scenario where you want to capture other information, then you use business or application exceptions. And in the business or application exceptions, you can store some additional fields which are related to the context in which the exception happened. And you should document all exceptions, all checked exceptions thrown by each method using the throws tag or the exception tag in that particular method's Java doc. And include appropriate details when creating and throwing exceptions. So if an exception happened for a certain reason that you found, then you add that reason as part of the exception message. So when you want to display that information to the user, you actually have information from the context in which the exception happened. And you should always throw exceptions which are appropriate to the context. And then we'll look at some demo programs which will explain all these concepts that we have covered so far.